All right, this is a walkthrough of the practice test for the third test, and the test is about truth tables. The main thing I want to do here is show you how I want you to do the truth tables online. I had to fuss around for a while. I wanted to try to find a way that you could have automatically graded truth tables, but that just didn't work out. So. So this is how it's going to work. There are actually 5 questions at the start that are just about the main connective, and these are only 2-point questions. So normally when I do this on paper, I've got a question that says, identify the main connective in the following 5 sentences, and that's a 10-point question. Now I've had to break that up into 5 2-point questions. But in any case, these should be fairly straightforward. So you look at number 1 here. A, if and only if B or C implies D and A. You've got all those brackets and parentheses on the left-hand side, grouping everything together. And so you know that the ampersand has to be the main connective. For the next one, you've got parentheses on the left and the right, and the and is going to be the main connective there again, right? For this one, the or is the main connective. Notice I've got an extra wrong answer here saying the bracket is the main connective. Okay. For number 4, it is the and for number 5, it's the conditional that is all the way on the right. Okay. Now we get into, and 6 is a short answer question where I ask you to say how to tell if a pair of sentences is equivalent given the complete truth table. So for this one, you're just going to get one of the tests that you have. You're going to have to explain one of the tests that you use a truth table for to identify a logical property. In this case, it's the equivalence of sentences, right? And we say that 2 sentences are equivalent. Well, 2 sentences are equivalent if the column under the main connective, the columns under the main connective match. There, that was 12 words, and that should be, and that's completely adequate. I guess some warnings here. Then one of the reasons why I wanted to have at least 15 words, and 12 words is close enough. Sometimes I get really short answers that are too vague. So people will say things like 2 sentences are equivalent if they match, or maybe just they have to match. And by asking you to write it out completely like this, I can be sure that you've got the full definition right. In fact, we can even add some more here. 2 sentences are equivalent if the main columns under the main connective in their truth tables match there. And you just specify that. Don't let any ambiguity slip through there. All right. Now we actually have to start writing up truth tables, and this is where I wanted to be sure to show you how to work the interface. So here we have a sentence, A and not A, if and only if not B and not B. And so I want you to do a full truth table for this and then use that to determine whether the sentence is a tautology, a contingent sentence, or a contradiction. And the best way to do this is actually to use the table function that is built into your that's built into Canvas, right? And I actually give you an answer here. The table is going to be 10 by 5. That helps part of your answer right there, right? So we know we can do 10 by 5 like that. And the header row is going to be the sentence that we're doing. And I don't want you to do the reference columns that go off to the left. So here, it's going to be, I'm going to copy and paste it to make it easier. A, and then we just want the parentheses A in that column, and the and in the next column, the negation in the column after that, the A parentheses there. I'm keeping the parentheses with the thing that they group. The parentheses don't need their own column. The if and only if gets its own column. Heck. The negation gets its column, parentheses B, another and, a negation, and a B, right? And so now I just do this the way I do any truth table problem. We know we start with the individual sentence letters, and we know that A is going to have this pattern, true, true, false, false. Now, will it let me select whole columns? No, it won't. Well, that's annoying. It's a lot easier if you can copy and paste full columns, but we can't do that. True, true, false, false. And when we go over here for B, it's true, false, true, false. And this B is true, false, true, false. Oh, now let's fill in the negations. So the F here, or the not A, becomes false, true, false, true. And the not, no, it doesn't. It becomes false, false, true, true. And then the B, the not B, is false, true, false, true. Okay, so now we have A and not A. You notice that there's always an F on one side or the other for this, right? There's an F on the right, and for the first two lines, then an F on the left for the second two lines. So this is this part of the sentence is a contradiction. Over there, we're always false. Same thing happens here. This is always false. But note that on this side, there's another negation sitting right here that we need to fill in. So the not modifies the column with the ampersand, and that becomes always true. Furthermore, the final column, the absolute main connective, is a biconditional. It wants the two sides to match. That means that the column that we just wrote all these T's in would have to match the column we wrote all these F's in order for the whole thing to be, in order for the whole sentence to be true. But it never matches. So in fact, this is always false. Right? And because it is always false, we know that the full sentence is a contradiction. So now I just want to write that on a separate line down here. Contradiction. And so for all of these, that's how I want you to fill in the truth table. It won't check it automatically, but it's fastest for me to grade. And also, doing the table like that will force you to look at everything. So, be sure it'll make it so that you see every column and that sort of thing. So it should actually help you to get the problem right. All right, let's do another one of these. A implies B implies A and not B. So this time it's going to be 8 columns by 5 rows. And, all of these are going to be 5 rows. I don't think there are any problems in the database that even ask. No, there are problems in the database that ask you to do 8-line truth tables. So that would actually be 9, including the header row. But we don't have to worry about that right now. 8 by 5. So, isn't it weird that it... Okay. We'll go there. And again, we want to fill in the header row. And I always prefer to cut and paste because I get fewer typos that way. So A, oops, the conditional gets its own column. The B parenthesis gets its own column. The A gets its own column, the and, the negation, and the B parenthesis. So A is, here, let's put on caps lock. For once, cap lock is useful. True, true, false, false. And B is true, false, true, false. A is true, true, false, false, just like last time. And B is true, false, true, false. All right, now let's do the negation. Not B would be false, 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 true, false, true. Let's go over here. This is another first level connective, and it actually fits the pattern for the negation or for the conditional perfectly, right? Because A and B are in the right order. So this is true, false, true, true. And then this, for this one, oops, I almost did the wrong column. Let's take a look at this carefully, right? This conditional here is the main connective for the full thing. We don't want that. The next connective we want to do is this and here, right? So the and is connecting the A and the negation next to the F. And the and says both sides have to be true. There's going to be one line where that's true, but this time it's not the top one. I'm sorry, it's not the top one. False, true, false, false. And now we can go to the conditional. So we're looking for a line where the antecedent is true and the consequent is false. And we actually have that on the first line here. So you see there is true and false. There's the false. There's the true. So that one is false. Okay. The next one has a false over here. So that one is true because the conditional is true when its antecedent is false. And then look, we get true implies false and true implies false twice. Oops, so this is true. And these two are false. Let's double check that. So we get true implies false is false. False implies true is true. True implies false is false. True implies false is false. So under the main connective, we've got a lot of F's, but we also have a T. So that means that the sentence is contingent. It can go either way. And we're done with that. All right, so the next problem is a logical equivalence problem. And the one thing that I want to do here is include a blank column between the two sentences that we're seeing, where we're asking whether they're logically equivalent. So this one is going to be a 10 by 8, or I'm sorry, a 10 by 5 table. And we're going to put this sentence here. Scroll up. I wish you could make this slot bigger. The not, the a, the or, the b, I'm sorry, the not, and then the b, and then we skip a row or a column, and then we say, oh, and I had an extra not in there because there's supposed to be one out here. Oh, I didn't when I was copying. You see, when I was copying here, I didn't copy that not, so that was a mistake. So we need to move everything over one. This is a not here. This is the or. This is the a. This is the first not, parentheses, not, and then this is the outermost not. And then we skip a line, and then we do a and b. All right, so we do our a's and b's. A, true, true, false, false. B, true, false, true, false. A, true, true, false, false. B, true, false, true, false. Now for the left-hand sentence, we can actually just immediately fill in the column that the column that represents the truth value for the full sentence, and it's true, false, false, false. So over here we just have the characteristic truth table for the and. Over here we need to do some nots, so it's false, true, and false, false, true, true. Now for this or, let's scroll up so that we can see the header row completely. For this or, we are comparing this negation and this negation. So false or false is false, and then all the other lines are true. This negation negates what was in the or, so that becomes true, false, false, false. And then you see that the column under the not there exactly matches the column under the and here. So we can just say that the sentences are logically equivalent. All right. Okay. Now we're comparing these two sentences, A or B, and not A if and only if B. You use the truth table function. So we want 8 by 5. 5 and then 8. Scroll up to the first row, A or B, not A if and only if B. True, true, false, false, true, false, true, false. And let's just fill this one in all the way because it's right there. This is just the characteristic truth table for the or. True, 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 false. Now, is that logically equivalent to what we're going to have over here? Not A if and only if B. So we get A is true, true, false, false. B is true, false, true, false. The negation comes next. That's false, false, true, true. And then the conditional the biconditional is comparing the negation and the column under the B, and it asks if they match. So we say that here they do not match, so it's false. Right? That's a T and an F, or an F on the left and a T on the right. Here it's two Fs, so it's true. Here it's two trues, so it's true. And there it's a true and a false, so it's false. The two sentences do not match, and therefore they are not logically equivalent. Oops. I'm going to get this so I'm not in that row. Not logically equivalent. All right. Now we're looking to see if this set of sentences is consistent. And since we're at this point, the table is actually going to be really wide. It's 14 columns by 5 rows. And to get that, we can't do that from the default here, right? The most we get right there is 10 by 5. And it's not giving me 10 by 5 for some reason. Let's try that again. There. But then once we get to the end, what we will do is go here and do insert column, and then so that 1, 2, 3, 4. And the spacing sucks. And it doesn't look like there's a way to do automatic spacing. Let's see if it adjusts properly as we go along. Here, we could do it like this. Copy the full thing. So for the first sentence, the first thing of the first sentence is the not. Then it's the A. Then it's the B. And then I want to skip a row or a column. A if and only if B. A. The next column is the if and only if. And the next column is the B. Skip one. And now we have not A or B. We want to give the not a column. And we give the A a column and the or a column and the not a column and the B a column. And it kind of adjusted, but not really. And I could probably fuss with these columns, but I don't expect you to, so I'm not going to do that. True, true, false, false. True, false, true, false. True, 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 false, false. True, false, true, false. And let's just finish this since it's right there. This is the characteristic truth table for the biconditional. So it's true, false, false, true. And then we can go over here. A is true, true, false, false. B is true, false, true, false. The not for that is false, true, false, true. And then the not for the A is true, false, true. I'm sorry. False, false, true, true. So that gives us the or, and this is actually the standard truth table for the or that has been flipped because the two sides are negated. So it's false on top, and then you get 3 trues. Okay, we go over here. Oh, that's the main connective. The main connective is that negation floating around out there. The first thing we want to look at is the and. So that's true, false, false, false. And then this becomes false, true, true, true. Now, if we look at this, we actually see that there is a row where all 3 of these sentences are true. on the bottom here, this sentence is true. This sentence is true right there. It's not highlighting a single letter. There. Now it's highlighting a single letter. That sentence is true, and this sentence is true. So that's all trues. So we say, therefore, that the set of sentences is consistent. So number 12. This was originally a 10-question test, but I had to break up the first question into 5 questions, so it became a 14-question test. And again, we're going to need 14 columns here, so what I'm going to do is insert a 10 by 5, and then when we go to the last, maybe if I highlight 4 columns, it's not going to let me do that properly, is it? Nope, it's not. So I'm just going to go 1 here. Maybe if I space it here, they'll be more evenly. 2, there we go. 3, 4. That looks a little prettier. They're not as scrunched up at the end. A and A or B is the first sentence. So we go A. Is it just not showing me? That might be too much for it to fit in there. So I'm just going to write that out. A and A or B. Skip a row. Now we'll try cutting and pasting. Copy. A implies not B. A, the implies gets a column. The not gets a column. The B gets a column. And then we can skip. And it looks like I didn't give myself enough columns, but let's try this again. All right, so that the not gets 1, the B gets 1, the implies gets 1, and then we'll just add 1 more for the B. B. Okay. Now we do the basic tables. I'm going to do this one sentence at a time. So we're going to go true, true, false, false. I'm just going to do the A and the B for the first sentence. True, true, false, false. It really doesn't matter what, well, there are lots of situations where the order doesn't matter. Obviously, there's some situations when you have to follow the order of the connectives. So this is true, false, true, false. But rather than going to the next sentence, I'm just going to go over here. The next connective is the or for this sentence. And this gives us the regular true, true, false, the characteristic truth table for the or. Now we go over here. We have the and. This and is uniting A and what's under the or. So we say true or true is true. I'm sorry, true and true is true. True and true is true. False and true is false. And false is false. So that's that sentence. Next sentence. True, true, false, false. And then the B is true, false, true, false. So for the not, we can say false, true, false, true. And then the conditional. So this is not going to be quite the characteristic truth table for the conditional because the negation, the consequent has been negated. So this is actually false on top because that's where you see your true implies false. And then it's true, true, true. Looks like we got a spare B there. Probably left over from the last thing. All right, and now, so it's not B implies B. So we have two B's, true, false, true, false, true, false, true, false, and we want to negate the first one. So this becomes false, true, and then over here, it's false implies true is true, true implies false is false, false implies true is true, and true implies false is false. All right, so now we want to see if there's any line where they're all true. And I want to look up here so I can be sure I'm looking at the main connective. The first sentence is true on the first two lines, so we can rule out everything else. But the next sentence is false on the first line. So the only candidate left is this line here. True, true, but then it's false here. So there's no situation where all three of these sentences are true, and we say that the set is inconsistent. All right, two more, and these are about validity. So what we're going to do here is we can use either partial or complete truth tables. I told you in the last video that you can, when we're checking for validity, we can work backwards. So what I'm going to do here is, show you cases where you start trying to work backwards and see whether that works or whether you have to go ahead and turn around and do it forward. So let's start with this argument. And let's try to do it backwards. So that's going to be 15 columns. And if we can successfully do it backwards, we may only need 2 rows. So we get 10 there, and then we can add some. 1, 2, 3, 4, 5. And then we'll add, so not A or B. The not gets a column. A gets a column. Or gets a column. B gets a column. Then we'll skip a row. Not A implies C. And then for the next one, I'm going to put the therefore in the column so that we can remember where the premises end and the conclusion begins. Not B and not C. All right, let's try this working backwards. If we work backwards, we start by assuming that the conclusion is false, right? So the and is false, but the 2 premises are true. So that not is true, and this conditional is true. Because it's not A implies C. There are no parentheses there, so the main connective is the conditional. Well, where can we do stuff? Well, there are 3 ways the conclusion can be false, but our first premise is a not, so that's helpful. And we can get, because that gives us a false here. If the or is false, then both A and B have to be false, right? If A is false there, it's true, it's false here, and true there. If B is false here, then the not B is true. Okay, so basically we've got one sentence left. It's C. Will this work? Yeah, check this out. You have a true implication with a true antecedent. Therefore, the T has to be true. I mean, the C has to be true. If it's true there, it's true there. And if that's true, then not C is false. Does this work? Yeah, it does, because we wanted the and to be false. And it turns out to be false because the right side, not C, is false. So we have found a line where the premises are true and the conclusion is false. Therefore, the argument is invalid. All right, next one. We'll try this using 2 rows. Here's the full thing. It's got 1 premise and 1 conclusion. So, table, and that is 2 by 10, and we just add 1, 2, 3, 4, and we fill these in. A if and only if B, that's our conclusion there. Then we get the therefore sign, then an A, then an or, then an and, I'm sorry, then an A, then an and, then a B, then an or, not, and, A, and not B. I gave myself an extra row there. Did I copy this right? So it's A and B or not A and not B. So A and B or not A and not B. A if and only if B. I guess we're okay. Well, there are 2 ways for the premise to be true, but there's only one way for the conclusion to be false, right? The conclusion is false if both sides are false. False and, I'm sorry. So the or is false, and therefore the and is false, and this and is false. There are lots of different ways we can go here. But we suppose we want the conclusion to be true. Well, in fact, we do. That means actually that there are only 2 lines that we can possibly be dealing with. One where A and B are both true, and one where they're both false. Does that work? Well, here we have true and true. Oh, we've already reached a contradiction. That doesn't work. What about here? Oh, yeah, because we want this line we want A to be false here. And now if we hit A and B are false, that's great. We still need that false. We need this false. If A is false, then we have a true here, and B is false, we have a true here, and that doesn't work because we wanted the and to be false, but both sides are true. So neither of these lines worked. What that means is we have to start all over. And I know that's a pain, and we're going to actually have to erase all of this stuff, and it doesn't even let you erase multiple lines because it is all the columns, all the rows that we were starting are things that would not work with the real deal. They all reached contradictions. So they are not patterns that would come up if you started from the beginning with A being true, true, false, false, and B being true, false, true, false. So I can now be pretty confident that this argument is valid, and I just need to write out the full truth table to show that. So A is true, true, false, false, true, false, true, false, and then so the premise is true, false, false, true. Go over here. Make the screen smaller. Will it all fit better? Yeah, it will. Excellent. True, true, false, false. True, false, true, false. True, true, false, false. True, false, true, false. So this one flips, becomes false, true, false, true. This becomes false, false, true, true. And then the and is false, false, right? False, true. And then over here it is the and is true, false, false, false. You unite those two with an or, and you get true for the top line because the left-hand side over here is true. False here because this is false and this is false. False here for the same reason, right? It's false under the ampersand there, and it's false under the ampersand there. And then finally it's true. So as it turns out, on the two lines where the premise is true, the conclusion is true as well. So the argument is valid. There are no lines where the premise is true and the conclusion is false. So get to the end of this, and we write valid. And that's the full test. And it's going to come up, and it's going to say that a bunch of these questions don't have answer. Oh, that one says they don't have answers because I paused the recording. When it gives you this partial grade, hopefully you've picked this up by now, it only is showing you the grades for the questions that can be graded automatically. And for this part of the recording, I didn't fill in any of those, so it's giving me a 0. The other questions have to be graded manually. All right, so that's what's going on there. This whole process is actually completely mechanical. So once you know the rules, if you follow the rules perfectly, it will always work out. So this particular part of the course really is just a pure matter of practice. And now we can stop the video.